So welcome all. Today we will do the experiment number 5. So the aim of experiment 5 is to produce an FSK modulation technique for digital signal. FSK modulation technique is a technique to transmit the digital signal over radio waves. So what we will do in this experiment is we define two frequencies for positive and negative part of the digital signal. So like here the positive voltage can be represented by a high frequency and negative voltage can be represented by a lower frequency. Like this, after the BPSK we will get output something like this, in which a higher part, a high frequency part represent a positive voltage part and the low frequency part will represent the negative voltage part. Okay. So the apparatus that we use in this experiment is function generator to generate square wave and DSO that will represent the waveform on the screen. It will similar to oscilloscope. Okay, and the IC that we use for the FSK technique is LM565. This IC is also used in the previous experiment for the frequency modulation. The IC basically hold a phase detector, an amplifier and a VCO. We also use the power supply of +5 and -5. Okay, and we use some resistance and capacitor to make the circuit complete. Okay, now come to the circuit part. So this is the circuit that we built on LM565. So the LM565 holds 14 pins, 7 on each sides. So on the first pin we will give the -VCC, and on the fourth pin we take the output, and on the seventh pin we give the input that is produced by our function generator. Okay, and the output is you can see on the DSO. You will see all the things in the experiment part, and here you can see on the pin 10th pin the VCC is connected, and similarly on the 9th and 8th VCC is connected with the capacitor and with the resistance. Thank you.
Hello everyone, welcome to the next section of lab 5. Okay, so you just learned about the circuit diagram and the aim of the lab. Right now we are going to look into the connection. So we did not look into the breadboard connections actually. So those of you are new to breadboards, so this is what we call as a breadboard. There are internal connections all throughout. Okay, so all throughout there are internal connections. So I'll just explain how the connections are made. So each of these 5 points, are a single connection. So you will have something around you have around 65 different vertical lines over here, and there are 2 columns of that. So there are around like 130 connections you can make over here and here, and then you have got these horizontal lines. So these are like from up to 5 points you are having 2 different connections. So the bottom line is a single connection up to the 5 slots, 1, 2, 3, 4 and 5, and from the 6th slot you are having a different connection, 1, 2, 3, 4, 5, and the top one is a different connection. So you have got 1, 2, 3 and 4 different connections over here. Similarly you have got 4 different connections to the top of the breadboard. So these connections we usually provide for connecting the power supplies or the grounds. So for a circuit, when you are looking into a circuit, you see that the ground connection is required by lots of devices or lots of different requirements. So you will take ground connections from these longer horizontal connections. Okay. Similarly, you will give power supplies to the top. You may give plus VCC over here and minus VCC to the bottom line. So that's how breadboard connections are being done. Let's look into the connection of our FSK. So we have got our LM565 IC. We have connected LM565 between these 2 slots. Okay. So this is how you connect an IC to the breadboard. Okay. So the point is that now as you have already seen, the first one is pin number 1 of the IC, and the last point here is pin number 7, and this one is pin number 8, and this last one is pin number 14. So this particular slot of the breadboard, these 4 point actually represents pin number 1. The next 4 are pin number 2, 3, 4, 5, and this is pin number 7. So for your particular circuit connection, pin number 1 is connected to minus VCC. So what will I do? I will connect a wire to pin number 1, okay, and then I will connect it to this top point. And this top point is where I will be giving minus 5 volts required for the IC. And the power supplies I will be taking from the power supply generator. So the power supply generator can give you plus 12 volt, minus 12, and plus 5 and minus 5. And this particular minus 5 connection I will take from the power supply, and I will connect it to this particular point. So that's how you usually connect an IC and power supplies to the breadboard. And the ground connection of the power supply, the black color that is coming out from the power supply, you will take that and you will connect to the bottom of the breadboard. Okay, so as given in your circuit diagram, the entire connection is being set over here. Pin number 1 is connected to minus VCC. Pin number 2 and 3 is connected to ground. So these pink colors are actually connected to ground. Okay, and pin number 4 and 5, pin number 4 is where you are going to take the output, and that is this particular connection. Okay, and then pin number 5 and 6 you have left outside, and pin number 7 you will be providing the input, and the input is the square wave of 4 volt peak to peak and 1 kilohertz. So let's just see how. So first of all, before you connect it to the breadboard, you have to generate the square wave from the function generator. Okay, so right now we have set 1 kilohertz and 4 volt square wave from the function generator. But you have to set this function generator, set this particular waveform, and you have to observe it on the DSO. Okay, so right now I have taken this input from the function generator and I have connected it to the DSO. So you have to verify that first. So I'll just vary the amplitude over here on the function generator, and you can see how the square wave gets modified over there. Okay, I'm varying the amplitude of the square wave. So okay, so you can see the amplitude is reducing. So the square wave that you see right now is 2 volt peak to peak. This is a much smaller square wave. Okay, and I will just now increase the amplitude, and you can see what will happen. Okay. So you can observe now that the amplitude is, I was changing the frequency. Okay, so now you can see that the amplitude got increased. Okay, so that's how you change the amplitude, and you can, there is a frequency variable over here, and that will vary the frequency of your square wave. And that square wave you have connected to pin number 7. And pin number 8 you have connected a 270 ohm resistor to VCC. Pin number 9 you connect to minus VCC. That's again to pin number 1 or to the top line that you have connected. And pin number 10 you connect to plus VCC, and that is plus 5 volt. So this particular IC you are using both plus VCC and minus VCC. That is plus 5 volt and minus 5 volt. And the output you are taking from pin number 4. Okay, so now we are observing the output of FSK. These fluctuations are actually occurring because the waveform is having more than one number of frequency. So here you can see that you see lower number of cycles in this particular area, and these particular areas you can see that you are having more number of cycles. When a signal is having like more number of, the frequency keeps on changing, you will see these kind of oscillations in the DSO. So the observed waveform is actually the FSK. You are having a lower frequency and you are having higher frequency as per your theoretical understanding. So when you are actually, if you are actually there in the lab, then you will have to take the measurements also. You will have to calculate the low frequency, what all are the actual low frequency and what all are the high frequency. The results looks fine, but you do not know the amount of pain that went into getting this result. Hardware experiments are kind of difficult. There may be many problems, many factors that is affecting the actual result. We were, few of us TS were there in the lab, and it took us around 2 hours, 2.5 hours just to get the result of FSK. So you should actually get the actual feel of hardware experiments maybe once you come back to college. Yeah, so that's basically it. Hope you understood all these analog lab experiments, and we will see you later with microwave lab experiments. Thank you.